Assalamualaikum and hello, my name is Muhammad bin Hamzah. I am a UTHM student in Bachelor of Mechanical Engineering Technology with honor in Automotive. So, in this video, I will present about my poster for final year project PSM2. My topic is selection and analysis performance of the rechargeable battery for electric go-kart development. And my supervisor is Dr. Muhammad Faisal bin Fushim. First of all is about abstract. Almost all go-kart built for marketing purpose and racing on the circuit use gasoline petrol as their power source. The use of gas does harm and good, especially to the environment. The objective of this project is to select the best rechargeable battery that can be used for an electric go-kart. This selection for the rechargeable battery is based on the criteria and description by research on the available source such as the internet and depends on the entire go-kart electric system, especially for the electric motor. The primary things for the rechargeable batteries such as lead acid, nickel cadmium, nickel metal hydride, lithium ion, lithium ion polymer, and all rechargeable alkaline battery are being researched thoroughly to understand the combination of chemical reaction are used in this battery. In order to obtain the best battery, it has to be the parallel with the scope of the project and suit to the criteria needed. Several types of rechargeable battery are listed and final decision are chosen by on the application analysis matrix and discussion between team members and my supervisor. The final phase of this project is to assemble all the components and parts of the electric go-kart. The purpose of this project carried is to ensure the battery is suited to the requirement of the entire electric system and its use can last longer. For the introduction part, the battery act as a power supply will be the main problem if the selected battery does not match the required energy power of the electric go-kart, which will affect the electric speed of the motor and the durability of the discharge time for the go-kart system. Second, the battery may cause the go-kart to be unable to move because the power provided is not enough to rotate the motor. For the objective as well, the first objective is to identify the suitable rechargeable battery for electric go-kart application in several battery attributes like output voltage, battery capacity, weight, mass, and cost. Second, to ensure that the power supply of the rechargeable battery is sufficient to move the electric motor. And third, to analyze the power consumption of an electric go-kart is required. And lastly, to ensure the battery can be utilized for 30 minutes for the time it's fully charged and until it's exhausted discharge. For literature review, the first one wrote by D.D. Study 2009, titled Modeling and Energy Consumption for Determination of an Electric Go-kart. The findings is the performance of the 24-volt 9 ampere hour nickel metal hydride battery in the electric traction drive system can support the electric traction drive system for 20 minutes and 51 seconds. This battery can fulfill the requirement that is specified for electric traction motor drive system. Second, T. Nobles, Wim Depress and Yves Pardon 2004. The title is about design of a small personal electric vehicle as an educational project. The finding is standard lead acid battery can be drained in 15 minutes, but the large weight is an important disadvantage. Nevertheless, they are used in this project for cost reason. And for the third, from Lodisimes, Globioski, and Premezlo Kubia 2017. The title is about analysis of vehicle dynamic parameter for electric go-kart design. The finding is was assumed that e-karting will be equipped with lithium-ion battery due to their best energy to weight ratio. Degradation of lithium ion depends on the condition, but it is up to 10% less capacity already at 300 discharge and charge cycle and 20% at about 100 1000 cycle. And fourth, from Emma Gundis and Emma Jensen 2009, the topic is about modeling and simulation of a hybrid electric vehicle for Shell, Eco Marathon and an electric go-kart. The finding is the nickel cadmium is about 80 years old invention, but the cost is about 4 times that of the lead acid. For methodology, first of all, I do learn literature review related in my topic. Any finding or problem from previous study will be recorded. Next, I will study about the parameter data and select the suitable rechargeable battery by making comparison the data like cost, power, safety and so on based on the several type of rechargeable battery. After that, I will study parameter to collect a data. Each connection of battery, either series or parallel, will produce different power output. When the battery is managed to support the electric motor 48 volt, I continue to install the battery into the go-kart. Then the experiment of capacity battery test will run. If the battery capacity can last for 30 minutes, the experiment will continue to the speed test. I have set 3 different rotational speed of motor, which is 570, 100, 500, 1500 and lastly 2000 rpm revolution per minute. The data or result taken will be compared each other. Then I will analyze and make a discussion about the data. Lastly, I will make a conclusion about my experiment and provide some recommendation to the next researcher. Then for regression matrix analysis, I have choose two top main battery type based on the literature review, where GP battery represent for the lead acid and lithium iron phosphate for the lithium ion. The scale is based on my research and discussion between my member and my supervisor. A low scale of 1 indicate the battery criteria are not suitable. Scale 2, the criteria can be used but are less appreciated, and a high scale of 3 indicate that the battery criteria are more suitable. So this is experiment procedure. Once the user assemble the component and parts of electric go-kart model, the battery cell will be placed on the go-kart on the back side. Make sure all of the battery cell must be appropriately stuck and firmly. Second, construct a wire connection between the battery cell and the load, which is electric motor or the charger, to make sure the wire connected according to the correct label, which is black for the negative terminal and red wire for the positive terminal. And third, the battery selected attached to the controller, which connect to the switch, throttle, pedal and electric motor. And fourth, switch on the electric go-kart. The speed of the go-kart is varied to minimum and maximum of the rotating electric motor. The data is collected and the data taken is in the form of voltage, time and current to find how long the battery can last and how much the power consumed. And lastly, the data of the experiment of speed are recorded and stored in specific file and to analyze. And then we go to the result. So the type of battery had been selected is the lithium iron phosphate battery. And this battery is selected based on the highest total scale in table diffusion matrix. Lithium iron phosphate battery based innovation has a higher heat and chemical durability, which means it has an excellent safety feature than lead acid technology. Lithium iron phosphate are inconventional in the event of improper handling when charging or discharging. They are more stable in overcharge or short circuit circumstance because of they are installed with a battery management system. Here in the table is the battery specification by manufacturer. Total I use a 16 cell of battery. This one is for get enough 48 volt that required by electric motor. By that, I calculate the total voltage of the battery is 51.2 volt. The total weight of the battery 11.28 kilogram. The size or the dimension of the battery is 22 centimeter length, 14 centimeter width, and 16.5 centimeter height. For analysis costing, the selected battery costs 992. For the additional safety, battery management system is 88 ringgit Malaysia, and for the charger is 112. So the costing is about 1192. Based on the data obtained, the voltage output produced by the battery to accommodate the electric motor is sufficient. The output voltage of the battery can supply 52.5 volt to the electric motor that only requires 48 volt. Although there is a one cell battery that has a low voltage level at 3.1 volt, but does not be any failure to supply the required voltage of motor electricity, because the average voltage is 3.28 volt for each cell. Likely, the low level voltage of the battery cell is in high discharge value percentage. Next graph show the voltage required by the electric motor from the selected battery, lithium iron phosphate. The x-axis represents the number of rotational speed of the motor, namely 570, 1500 and 2000 in units of revolution per minute, while the y-axis represents the voltage required by the motor. The trend shows that the higher the rotational speed of the motor, the greater the voltage to be applied. It is because the electric motor requires more power to rotate the electric motor. The third graph has shown the rotation of the motor speed against the power consumed. The x-axis represents several levels of motor rotational speed, which is 573 rpm for minimum, 1500 for middle, and 2000 rpm for maximum value. The trend shows the more rotational speed of the motor, the more power will be used. This is because power affects the speed in moving the motor. As the power law states, the power is equal to the voltage difference across the element multiplied by the current. So, if the rotational speed increase the voltage, then the power will also increase. And last graph show for the battery performance analysis. Show a bar graph represent the x-axis of 3 motor rotational speed, which is 570 rpm, 1500 rpm, and 2000 rpm against the time taken from full battery capacity 100% to depletion 0%, and also up to the point suggested by the previous study, which is at 80%. The trend show that as the rotational speed of the electric motor increase, the time taken for the battery capacity to reach its level of discharge is decreased. The time for the battery to run out depends on how it is used. The power from the battery will decrease, indicating that the battery is depleted. For battery discharge cycle, the discharge cycle data were taken based on the voltage generated from a fully charged battery until the battery was fully discharged. The experimental test was carried out by setting the angular speed of the electric motor to the highest value of 2000 rpm revolution per minute. This is to ensure that to keep the same value of the current and voltage required by the motor while rotating. From the recorded data, the graph was plotted according to the voltage against the discharge percentage, as in graph below. The pattern of the graph show a decrease, and there are at some value points where the graph is flat at a certain discharge percentage. This can be shown at a discharge value of 10% to 70%, where the voltage required by the motor to reach and be consistent at the maximum angular velocity level is still adequately supplied by the battery voltage. For charging rating, this segment is analyzed depending on the current flowing out of the charger. The value of the output voltage of the charger is same as the battery, So no evaluation was done because there was no difference. The figure represent the charger selected for lithium iron phosphate. In fact, this charger also works to convert alternating current to direct current. This is specification for manufacture had to be not, which the charge and discharge is constant current and constant voltage. So this one is suitable for lithium iron phosphate battery. Different type of battery with different the type of charge and discharge. So for the voltage output is 54.6 volt and the current output is 10 ampere. The charger output is suitable because in range between 58.4 volt maximum voltage for the cell battery and 51.2 volt the lowest output voltage by cell battery can be produced. For the current, so the current charger maximum is 25 ampere, but the comment from the previous study state that it is recommended to use half from the battery capacity, which we can get 12.5 ampere. For selected charger current, 10 ampere is not too high and not too low. The excessive current cause electrochemical process to accelerate or increase when the temperature rise, so resulting in greater ion and local particle movement inside the material, resulting in the increased internal resistance of the battery. Indeed, a low current will increase the time required to charge completely. So for the charging time, for the battery to full charge is about 2 hours 30 minutes. In conclusion, all of the objectives in this project study have been achieved. The resulting results are based on formula, calculation and experiment. The result can serve as a guideline to researchers and developers in the field of go-kart development. Among the aspects that need to be given priority is such as voltage, because it plays a role in whether the power produced is sufficient with the power required by the go-kart electric system, especially the motor. Second, the matter of the battery capacity should also be taken into priority in choosing a battery, because it determines the battery time for the battery to be used from full charge to depletion. And lastly, the manner to use the battery also play as a role, as the higher the power consumption, the faster the battery to run out before being recharged again. Last but not least, the reference for my literature review. That's all for me. Thank you.